Okay, welcome back, kiddos. Now we're moving on to lesson 2.2. We're talking about inductive and deductive reasoning. So we're talking more about logic. Okay, so let's start out with we're going to talk about inductive and deductive, as we said. So let's first start with inductive reasoning. Okay, so the term inductive means we use specific examples to come up with a prediction. Okay, so we use specific examples to come up with a prediction. So imagine that you had these examples over here. Let's see if we can come up with a prediction on these. Pause the video and see if you can come up with a prediction here, here, and here. Okay, let's see. This prediction 4 to 8, 8 to 12, 12 to 16. What would you say? I would say the rule is plus 4, right? So you would think that that is 20, right? Because 12 plus 4 is 16, 16 plus 4 is 20. All right, what about this rule? Well, if I see this difference, it's less, is 5, right? That's minus 4. This is minus 3. So I think the rule would be, on the next one would be minus 2, right? So that one should be 6. Okay, so we just go down 1 each time on this one. Okay, so now what's the rule on this one? If we go from Monday to Tuesday, looks like we're going the next day. Okay, so on these, we're just making a prediction based off of specific examples. That's called inductive. All right, so now let's talk about deductive reasoning. Okay, so deductive reasoning is we're not using specific examples. We're just using facts, rules, definitions, and properties. So things that we know, we're going to use those to find logical conclusions. Okay, so we're going to use our knowledge to make logical conclusions. So for this example, on Fridays we drink great Gatorade. Today's Friday. So using that rule that we said that on Fridays we drink Gatorade, today we will drink grape Gatorade. Okay, so that's when we use the rules or facts that we know to come up with a conclusion. All right, inductive uses examples. All right, so next, conjecture. Okay, what is a conjecture? Okay, a conjecture is an educated guess, so not just a guess, but an educated guess based on known information. So we can only go off what we know. Okay, so make a conjecture based off the following information. Point A is in between point A and C. Point B is also equal distance to A and C. So what kind of educated guess can we use based on the known information? Well, if we say that point B is between A and C. So A and C. Point B is somewhere, but it says it's equal distance to A and C. So if it's equal distance to A and equal distance to B, we can mark it with this. We would say that point B has to be the midpoint, right? Okay? That's based off our previous knowledge. So we'd say point B is the midpoint of line AC. Okay, so that's what a conjecture is. Now our final statement word from this is a counterexample. So a counterexample. So you might think counter is against an example. It's counterexample is what proves a statement is false. Okay, so with the counterexample, you only need one to prove that it's false. Okay, you only need one counterexample to prove that it's false. So what if I said, okay, what's a counterexample of this following statement? Okay, provide a written picture, answer and picture. So a counterexample of this: any two lines are always parallel. Well, do we have a counterexample for that? What's one statement that can say that this is false? It says any two lines are always parallel. Well, what about if I had something like this? These are two lines and they're not parallel, right? What if I had like this? That would mean that these are perpendicular, right? So all lines don't have to be parallel. Parallel. Okay, this is a picture that shows that, and then let's use words. We can say that two lines can be perpendicular. Right? And we know that perpendicular means 90 degrees. So two lines don't always have to be parallel. All right, let's keep that in mind as we go on to our next page, moving right along. So now we're going to talk about two types of deductive reasoning. Okay, there's two types. So the first type that we're going to talk about, is called law of detachment. Okay, law of detachment. Then we're going to talk about the law of syllogism. Okay, so I know these are new words, but we can do this. All right, law of detachment. The first one, law of detachment. What that says is if P then Q is true, right? So if we do P, then Q is true. If that's a true statement and P is true, then we know that Q is also true. Okay, so if P is equal to Q is true, then we know that Q is true. So if we say it's raining outside, if it's raining, then it's wet outside. On Thursday, it was raining. Therefore, we can say on Thursday, it was wet outside, right? Okay, because we said if P, then Q is true. If it's raining, then it's wet outside. Well, on Thursday, it was raining, so we can say that it had to be wet outside on Thursday. All right, so let's use the law of detachment to determine a conclusion on this one right here. Okay, if the measure of an angle is greater than 90, then it's obtuse. The measure, this should be up here, the measure of angle ABC is 90. What's your conclusion? Well, if the measure of an angle is greater than 90 and it's obtuse, and the measurement of this angle is greater than 90, then we can say that angle ABC is obtuse, right? That's using our using the law of detachment with math, right? If we know that if it's greater than 90, it's obtuse. If this is greater than 90, hey, it has to be obtuse. All right, next, we're going to talk about law of syllogism. So that was detachment. So law of syllogism, what that says is, if P then Q is true, okay? So if P then Q is true, and Q then R is true, then that means P then Q R is true. So if P then Q is true, and Q then R is true, then P then R is true. So we can think that we cut out the middleman. Okay, so we can cut out, we can cut out that and go straight from the P to the R, right? Because if we said P then Q is true and Q then R is true, that means that P then R. All right, so we cut out the middleman. So let's check out this in just regular words. All right, so if you upload your own videos to social media, then you're a content creator. If you're a content creator, then you should be kind to others. So a conclusion is, if you're a content creator, then you should be kind to others, because if this is the same, this is true, we can cut out those middlemen and we can just say, if you upload your videos to social media, then you should be kind to others, because these two are both true. Okay, so let's use this. Use the law of syllogism to determine a conclusion. If two lines are perpendicular, then they form a right angle. If a right angle is formed, then the measure of the angle is 90 degrees. Okay, so we can say, cut out the middleman using that law of syllogism, right? It says cut out the middleman using the law of syllogism. If two lines are perpendicular, then the measure of their angle is 90. If two lines are perpendicular, then the measure of their angle is 90 degrees. Okay, so that's the law of syllogism. We cut out that middleman, so that's what we want to think of on that. And then the law of detachment. Okay, if P is Q and P is true, then Q is also true. Okay, so let's keep that in mind as we go to our practice for today. So today's practice is going to be on quizzes. All right, so go to your quizzes now. Right now, go to quizzes and do those problems. All right, if you have any questions, just let me know.